It is 3rd of November, 2024. I will briefly talk about data structure. In data structure, there is lift, which is linear data structure. Uh, I will talk about complexity first. Complexity, there is time complexity and there is space complexity, which is how much time will take during the algorithm execution. Can we define Markov process? It can be one question that maybe we can try it, but this is just summary, so I will pass it. Big O notation is upper bound, and big omega notation is lower bound, and big theta is average, is what we use. We should able to calculate like how, how much complexity we have during the Hanoi to solve Hanoi problem and to solve or to execute binary search tree. This is very important issue. We will later discuss about how can we calculate, and if we will talk about data structure with Java. So if we quickly look up Java, then there will be ADT, which is abstract data structure. And we will extend or we will inference it to implement the structure. There is polymorphism and a lot of terms regarding objective-oriented programming. So there is lift, which is linear structure. We can implement a function like, if we want to use lift, not only as integer data type, but also use string and also other data type together, we can then use E extends comparable. So this is what we using generics. So we can input a lot of other data type, but what we should be careful is if we use E extends, then we should use A dot compare to is A dot compare is bigger than or smaller than. We should compare like that. We can't compare by using this mathematical notation. That is, I think, what is important in lift. And if we go to linked list, what is important is you usually make node and you usually make linked list node. You can make node head and you can make also node be, there will be node head and there can be back, and you should point it to maybe it is null or others. You should point it by next. And there can be problems such as problems such as reverse the order, or combine it, or delete it. This kind of operation is what you should do in linked list. There will be singly linked list, doubly linked list, circular linked list, and array list. You should distinguish the four types, and you should distinguish about how operation is how does operation is different, and how the node is different by their data type. It is very important. And for data structure stack, you need to think about another thing. Stack is very simple. If you put it and put it and put it, then when you go out, the last one will be go out first. This is the basic thinking of stack. When you implement the stack, there will be some issue that you should think about, such as in stack, there can be such problem regarding operand. If operand came out, then it is very important which type of expression it use. If it is infix, then there will be like a plus b. If we say there is a plus b, multiple c. If it is infix, then if it is postfix, we will write it as ab plus c multiple. It's somewhat different, so you should carefully distinguish when it goes to infix to postfix. It is very important thing. And for the divide and conquer algorithm, it is different algorithm, so I will pass it here. But we usually use divide and conquer algorithm when we segment through the line. We can make back with the data structure we learned from now on. Maybe we can design public interface back which have current size and which have Boolean to check if there is integer is empty or is full. And there can be some function that clears it. In data structure, it's not an algorithm class, but recursion to iteration algorithm is really important. It will solve so many skills, so many algorithms very easily. Recursion to iteration. Let's say there's some function which is designed recursively. Then there can be tail recursion. I will submit in next time I will show the very specific code. I will show you very specific code, but right now I will just write it as tail recursion. Then you should be able to change it to iterative. And for the complexity, factorial calculation will be theta n, and Hanoi tower will be theta 2n, and binary search will be theta log n. And there comes tree, which is non-linear data structure. And here it is very important to notice that if operands come out, then we should be able to distinguish between in order, pre-order, and post-order. Which is kind of weigh what node we should go first. In order, we will those three will has difference of which node you go first. It will be top, middle, or left, or right. And there's a lot of terms that you should remember to solve tree. There should be level, then there will be roof, there will be leaf, height, depth, size, interior node, and also about path. And we should be able to check it is binary tree or not. Binary search tree is binary tree that can be searched because we will make it in dictionary type. Next time we will check about one by one for implementing the algorithm. Thank you.